Again, it says to describe how each one is related to sine of x, we are going to graph all of them as well and start to see when we put all of these things together, what kind of shortcuts can we do for graphing? So the first one, y equals 3 sine of x. What gets changed? Your y values. So if your y values normally went from 1 to -1, they now go up to 3 and down to -3. So in a sense, that first value is affecting our amplitude. The period doesn't change. So again, I would start with one period of 2 pi, split it into 4, and say, where does a sine graph normally start? In the middle going up. Should label these 4 sections. And so we start in the middle, going up to a maximum, down to the middle, down to our minimum, back to our middle. And you would normally graph it again. I'm going to graph it with arrowheads to start here. It would normally continue on for this, but this question said sketch it between 0 and 2 pi. So then I'm going to take out my eraser and just graph the section that was asked for. Partially because I like using the little eraser so much. So pretty. Perfect. For part B, sine 3x. So now that sine of 3x is going to affect things horizontally. It's going to affect our period. So it will still go up only to 1 and -1. But our period, instead of being 2 pi, is going to be 2 pi over 3. Now I'm strategically putting that 2 pi over 3 there and splitting it into 4 equal sections. And I'll show you why in a second. So my new period is 2 pi over 3. Half of 2 pi over 3 is pi over 3. Half of pi over 3 is pi over 6. And 1 pi over 6, 2 pi over 6, 3 pi over 6 here. 3 pi over 6 could reduce to pi over 2. It's a sine graph, so where does a sine graph start? It would start in the middle going up, back to the middle, down to your minimum, back to your middle. And so if I was just asked to graph this, I would put arrowheads on and say it continues on forever. However, in this case, it said to graph it between 0 and 2 pi. So I can take out my eraser on this side, because I don't need to go any further on this side. It needs to start at 0. But I need to continue on the other side. And so if we want to go up to 2 pi, since our period, since we had a compression by a third, instead of having one period between 0 and 2 pi, we will now have 3 periods between 0 and 2 pi. Another 2 pi over 3 will get you to 4 pi over 3, which you could split into 4 sections. And then another 2 pi over 3 from 4 pi will get you to 2 pi, which you could split into 4 sections. And you continue going middle to maximum to middle to minimum to middle to maximum to middle to minimum to middle. Whew. So when we had our period, when we have this horizontal compression by a third, what that'll end up doing is causing 3 periods where you normally had 1 period. So normally we had 1 period between 0 and 2 pi. But by squishing it or compressing it horizontally by a third, we will now have 3 periods between 0 and 2 pi. So I marked 2 pi over 3 right here. Does that make sense that that's 1/3 of 2 pi? 2 pi over 3. I marked 2/3, and obviously at 2 pi that will be 3/3. And every 2 pi over 3, or every third, now will have a complete cycle. So I divided each of those sections into 4 and went middle to maximum, middle to min, to middle to max, to middle to min, to middle to max, middle to min, and so on, until we were finished at 2 pi. Whew. And it is so much nicer when they don't give you a domain, because you could just go from 0 to 2 pi, put your arrowheads on the end, and you're done. And for the most part on final exams, that's what they do. And the questions usually say graph at least one period. So it allows you to graph that one period, put arrowheads on the end, and you're good. But for these ones where they say a specific domain, we can still do it. It just takes a little bit of thinking. And finally in C, this is the first time that we've had a vertical shift. That +3 would move it up 3. So when things get moved up 3, our sinusoidal axis, our center line, our average, was at 0. Now, that average, that center line, is going to be at 3. So it's not an asymptote, but we can draw it like an asymptote. We can draw a dotted line. You've used dotted lines for asymptotes. You've used them for axis of symmetry in parabolas. What a dotted line often shows in a graph is it says, this isn't part of my graph, but this helps me draw my graph. And the center line helps us draw our graph. What is the amplitude of this one? The amplitude, so are you starting to get used to whatever numbers in front ends up being your amplitude? The amplitude in this one is 1. So if your center line is at 3 and your amplitude is 1, what's your maximum value going to be? Your maximum value is going to go up to 4. What's your minimum value going to be? 2. What's our normal period of sine? 2 pi. So once again, we mark 2 pi. We split it into 4 equal sections. And where does sine graph start? In the middle, going up. So where's our middle now? That's where that dotted line comes in now. Middle going up, so then it goes to a maximum, which is 4. Back to the middle. Down to the minimum, which is 2. Back to the middle. And again, normally we would add those lines on to say it continues forever. Because they wanted us to graph between 0 and 2 pi, we could stop. From there to there. So these are all of our basic transformations. We've shifted things left and right. We've shifted them up and down. We've stretched and compressed them vertically, which changed our amplitude. We stretched and compressed them horizontally, which changed our period. Next, we're going to combine them all. Yay. Wow, I haven't seen so many looks of joy in one place. Okay, so questions 6 and 7.